All right, you guys ready? Class.
Yes.
Danny. There we go. See? I know, right? You got this, Danny. You got this. You can do it. You can do it. It's all up to you. Good. All right. Okay, limits and continuity. Limits involving infinity. So we're going to work on to infinity. Thank you. All right, good. Yay. All right, and beyond. All right. Learn about squeeze theorem for limits at infinity, asymptotic, unbounded behaviors of function, end behavior functions. Limits can be used to describe behavior of functions for numbers large in absolute value. Symbol, infinity. Okay, finite limits, okay, as x approaches plus or minus infinity. So infinity does not represent a real number. It is a behavior. I would refer to it as an idea, because can you put infinity on a number line? No, it's an idea. So it's really not something. So it's not a real number, and it's just an idea of what represents numbers. For example, we can say that the limit of f as x approaches infinity. We mean that the limit of f as x move increasingly far to the right on the number line. We say limit of f as x approaches negative infinity. Right? We mean that the limit as f as x moves increasingly far to the left of the number line. So yeah. So to the left, to the left, to the right, to the right. Not cha-cha. Yeah. Okay. Too much for you guys. Too much. All right. Line y equals b is a horizontal asymptote of a graph of function if either goes to the right, the limit's going to be b, or it goes to the left, the limit's going to be. So on that previous problem that we just did on the warm-up right there, we actually had a horizontal asymptote, right? So what is happening is, so I'll bring that back up. What is happening is, as it goes further and further to the left, it's approaching this number, which I'm going to tell you it's 9. Same thing is going to happen to the right. But if you notice, they're coming from different directions, aren't they? Yes? And that horizontal asymptote is the MC hammer, because you can't touch this. So as it's approaching it, it's getting closer and closer to 9, but never really getting there. Does that make sense? Yes. So it's approaching 9. Use graph table to find limit as x approaches infinity and x approaches negative infinity. And f of x of c, identify all horizontal asymptotes. So use your graph. You have a calculadora right there in front of you. Yes, everyone should have a calculadora, because that's what good students do. Good students bring their calculators to class. I'm sorry. Did you say you want some cheese with your wine? Because that's all I got. No, the bread. That's my favorite broom. This is a magical broom.
Yay.
So I got that magical from my friend Kiki. She runs some type of delivery service.
Oh my god. Oh my god.
All right, did you all graph it?
I'm trying to remember how to erase.
Doc B. The button doc, the letter B. Yes. Huh? What's wrong?
It's dead.
Okay, come on over here and wipe it out with hopefully one that works.
There it is.
Yeah, sure, please. Second, let me see if I can grab you a different one.
I've never been seeing your bathroom pass. Wow.
Okay, which one? That's the current one. This one is
What?
code brown. You got a code brown. That's what you got to use. All right, use that. All right, so use this. So let's go ahead and take a look at it. So 1 plus x over x. I'm going to just hit doc, letter B, and go back here, control divide, 1 plus x over x, graph. There you go. So what do you think is happening here? Do I have any asymptotes? Yes. I have a horizontal asymptote. Do I have a vertical asymptote? Yes, I do.
Oh yeah, you do. Yeah.
Where is the vertical asymptote?
Y equals 0.
At 0.
Y equals 0?
X equals 0.
X equals 0. Okay.
So x equals 0. And where does it look like I have the horizontal asymptote?
Approaching 1. 1.
Okay, so it is at 1. So let's see. Okay, we have that here. So find the limit as x approaches positive infinity. Okay, so as the limit, x approaches in positive infinity of f of x, we get what? So that means going to the right, that's the positive infinity. It's on your graph.
Right. As x approaches positive infinity.
Yep. Keeps going to the right. What's happening? Yeah, it's going to the right. But what is the y value it's going to?
Approaching 1.
1, right?
Yeah,
Yes.
1.
It is approaching 1. Very good. Okay, now let's do the other way. So let's go the limit as x approaches negative infinity of f of x.
It's still 1.
It's still 1, right?
Yeah.
Okay, but this time it's approaching it from the bottom. It's approaching 1 from the bottom. On the right side, it was approaching it from the top.
Oh, you meant the direction.
Yes,
Yeah.
it's going this way. And so the graph looks kind of weird, but it's approaching it there. Now, what about asymptotes? So we have an asymptote at where?
1.
X equals
Oh, x equals 0.
0, and that is what type of asymptote?
Right.
What type of asymptote is it at x equals 0? Thank you, vertical.
Okay.
Okay, and what about the other one? At y equals
1.
1, very good. Y equals 1, that is a
Horizontal.
very good horizontal asymptote. So there we go. So we now have our asymptotes. We know that those are undefined. My graph shows me that they're undefined, and it shows me where it doesn't work. So the whole thing breaks down. Sandwich theorem revisited. So squeeze theorem also holds for limits as x approaches plus or minus infinity. Find the limit as x approaches infinity for cosine of x divided by x graphically and using a table of values. Now, go ahead and graph it. Make sure it's in radian. And then the next thing, I'm going to show you how to do this because hopefully it will make sense after we talk about this.
How do I get to radians again?
Okay, upper right-hand corner, what does it say?
Right.
It says rad, so you're good. So hit doc B, clear it out again. And it was control divide. My function is cosine x over x. So trig cosine x over x. Dang, look at that. That looks kind of wonky, doesn't it? That one looks pretty easy, right? Easy stuff. Is there an asymptote? Where?
Vertical asymptote.
X equals 0. So there is a vertical asymptote, x equals 0. Okay, so now we're going to look at this. So as it approaches infinity to the right, as x approaches infinity to the right, what's it look like it's doing? So we got it graphically, and then table. So what's it look like it's going to on the right-hand side?
Okay, repeat that.
What's it look like it's going to on the right-hand side?
Infinity?
Oh, that's what the x value is, but when we're talking about limits, we want to know what their output is. What's the y value as x is going to infinity? What's the y value there? Yep, 0. Looks like 0.
Wait, can you show that? Because
Look, it's wrapping, it's going here, right? Is it wrapping around the x-axis?
Yeah.
As it goes to the right, it's wrapping around the x-axis. Menu, table, split screen. Okay, so let's keep looking. So I am only dealing with right side, right? So those are only positive numbers. So as I just keep progressing down here, I can keep looking and get bigger and bigger and bigger, but what's happening to my values, my y values, as I keep getting bigger? What's happening here? Look what's happening. Look at these numbers. Look at my y values. So as my x values gets bigger, my y values, I got 0.006, I got 0.019, okay?
it just keeps getting.
Looks like they keep getting smaller and smaller, but they're alternating in between positive and negative, aren't they?
Yeah.
As we go, so as the limit approaches infinity, it gets closer and closer to 0. Now, I gotta assume that you guys know some of the stuff. The flashcards I gave you, those are important because those things have a lot to do with this and the trig stuff and all those things. So you need to know the trig circle. Now, let's take a look at this. So the cosine, if I were just to look at the cosine by itself, what is the largest number on my unit circle? I could keep putting in big numbers for my x values. What's the largest value I can get for my y value with cosine x? What is your largest value?
Like in radians or?
Yeah, radian, degrees, but this one I want the y values.
1.
1.
Yeah.
Okay. And what's the smallest number?
0.
-1, right?
Oh.
It goes in between 1 and -1. So if the largest number I can get here is only goes up to +1, so I, at the most, at infinity, let's say that this becomes 1. But what about if I'm still plugging in infinity or large numbers in the bottom? So if I'm plugging in large numbers in the bottom, think of it like this. There is seven people in this class. I'm going to get a pizza. I'm going to slice it up, right? I'm going to put it 7 slices. Okay? And so with one pizza, 7 people, everyone gets 1 slice, right? But now, because we're taking that one pizza and dividing it by 7, everyone gets 1 piece. But now I'm going to invite my other class. So now I still got that 1 pizza because I'm kind of cheap. Okay? That 1 pizza, now I'm going to divide it by both classes together, which is going to give me, 48. So I'm going to have 48 kids now. What does that mean about your slice of pizza?
Good smaller.
It's going to keep getting smaller, right? And now I'm going to add all my classes. So it's going to be up to 178 right now. I'm going to have 178 students. So I have my 1 pizza, and I'm now dividing it by 178. What do we know about our slice of pizza you're going to get?
It's not existent at that point.
It's going to be really, really small, right? So as the number of students that I divided by, your slice of pizza keeps getting smaller. So if you think of it like this, because the limit on the top is 1, right? It's my 1 pizza. That's the most I can get out of that cosine. The bottom, I'm going to keep dividing it by a bigger and bigger and bigger and bigger number as I'm going to infinity. So that means that anytime I see something like this, what is it eventually going to end up as? 0. It's always going to come out to be 0. 1 divided by infinity is 0. 10 divided by infinity is 0. 5 million divided by infinity. 0. Infinity is an idea, not a number. And so if you keep dividing it infinitely, keep going, you'll eventually just get down to no one gets nothing, that's 0. That's how socialism works. Socialism right there. Okay, as a math problem. All right, so properties and limits as x approaches plus or minus infinity. Okay, so right here, real numbers, plus or minus infinity, we get the limit. Okay, right here, g, m, then sum rule. If we're adding them two limits together, I take my y values and I just add my y values together for those two functions. So when I'm talking about the limit, I'm talking about the y that I'm getting out of it. I have an input of what's happening, and then if I have a value, a numerical value that comes out of it, I can add those two numerical values from f and g together at the end. Same thing for a difference, which is just subtraction of those two, if those two exist. Product rule, I'm multiplying them together. Quotient rule, dividing them. Constant multiple, I'm multiplying them by a constant, like 5 times the limit. So I would just make my answer multiplied times 5. That's what that means. Power rule, same thing, the limit is the same. Okay, infinite limits as x approaches a. If the values of a function f of x outgrow all positive bounds as x approaches a finite number a, we say that the limit of f of x as x approaches a is equal to infinity if the values of f become large and negative, exceeding all negative bounds, and as x approaches a finite number a, we state that the limit as x approaches a, f of x is equal to negative infinity. Does that make sense? No, it doesn't, right? Let's try this. So, right here, so what this is asking for is kind of like what we're talking about here. Now, if I'm looking at this and I say, hey, what is the limit as x approaches 0 from the left? As x approaches 0 from the left on this one, what's happening? X approaches 0. 0's right here in the middle. As x from the left approaches 0, where's my line going?
Downwards.
It's going down, right? Is it ever going to be equal to 0?
No.
No, because we know at 0 is a undefined. And what is that special word?
Vertical asymptote.
Yes, vertical asymptote. So that's an asymptote. So now, as it's approaching it from the left, I could say that my limit is going to be negative infinity. What about my limit as x approaches 0 from the right? I read it from the right-hand side. I follow it closer and closer to x, and as it's approaching x, it keeps going up right here, right? So I can say as x approaches 0 from the right-hand side is going to be positive infinity. So now, does the limit exist at 0?
No.
Why?
Vertical asymptote.
Nope.
Oh, but left side and right side can't.
There we go. They have to go to the same number for the limit to exist. So if both of them are going down, I could say that the limit goes to negative infinity.
Oh, okay.
If they're both approaching that. So let's go back to the notes. Okay, find vertical asymptotes of the graph and describe behavior of this to the right and left of each vertical asymptote. Now, I'm going to go off on another page. I think I have it here. Off to the side, we're going to do the math on this one.
They're right.
Page. So it was 8 over 4 minus x squared. Now, we got to do some factoring here. Factor the bottom. This is one of the things that you guys should be able to factor. It is one of the cards I believe I gave you. Okay, factor it. What is the bottom going to give me?
X minus 2 and then x plus.
What's a special word for this? Say it again.
Square.
No. It's part of your vocabulary. Those flashcards that I've been telling you to do. I know some people are not. This thing and this thing. So what is the thing in the middle? This is the minus sign, right? What's another word for the minus sign? No, not negative. Here's a hint. Right here. It's on this page. If you have a minus, that means it's a difference. Okay? You should automatically hear some little ding in your brain. Difference of what?
Difference of the square.
Difference of two squares. Is 4 a perfect square?
Yeah.
Yes, it is. Are you eating that? Don't. Bad. Bad. Don't. Okay. This is also a perfect square of x squared. So it's going to be a 2 plus x and a 2 minus x. So I have my difference of squares. Now, there is a rule in math. You will get a asymptote or undefined when? When is it undefined?
When the bottom is 0,
Thank you.
the denominator is 0.
Take that out of your mouth, dang it.
No.
When denominator equals 0. So what we're going to do is we're going to use the zero product rule, which says 2 plus x, 2 minus x equals 0. So if either one of these two things here equals 0, using the zero product rule, that means all of it will equal to 0. So I'm going to separate this into two separate equations of 2 plus x equals 0 and 2 minus x equals 0. All right, let's get the x by itself. So minus 2, x equals negative 2. Right here, minus 2, negative x equals negative 2. Divide by negative, so x equals a positive 2. So if I plug in negative 2 into this first one, it's going to be 2 minus 2 is 0. So that means no matter what this other thing is, anything times 0 is?
0.
Thank you. So that's going to go away. It's going to make this whole thing 0. So we have right here, those things are where my function is undefined. Okay, it's going to be undefined there, and it's normally going to be some asymptotes depending on what we have. So let's go ahead. We got those there. Okay, describe the behavior. Values of the function approaches negative infinity to the left of negative 2. Okay, so let's go through and insert do a quick number line here. So negative 2 and then positive 2. Here is my thing. This is 0. So it's asking, what is it doing? Values of the function approaches negative infinity to the left of negative 2. All right, what's going to happen to the left of negative 2? So at negative 2, this is going to be 0, right? Yes. Okay, so now what about 3? What about negative 3? What's going to happen at negative 3? Negative 3 squared is?
9.
4 minus 9?
Negative 5.
Negative 5. So it's going to be 8 over negative 5, right? Okay, let's do it again. Let's go back further. Let's go negative 4. What is happening from here?
8 over negative 13. So it's smaller.
8 over what?
8 over negative 13.
Keep going. So let's go a bigger number. Let's go 10. 8 over, so that's going to be 100. So 4 minus 100. Negative what? Now what's happening here? Do you notice what's happening?
Your pizza is getting smaller.
Keep getting smaller, right? So it looks like it's going to what?
0.
Looks like it's going to 0. So you're saying it's going to look like it's going to 0 here. Okay. The values of the function approaches positive infinity to the right of negative 2. Okay, so as it's going, so in between these two right here, it's kind of weird. So let me skip down to the bottom. Right here, the values of the function as approaches positive infinity to the left of 2. Wait, where's the other one? I went to the right of positive 2. Left and right, left and right. Positive 2. The right of positive 2. Where's the right of positive 2? I know, I'm looking for it. So it's left of negative 2, and I want to see right of positive 2. Yeah, it's being weird that it didn't state that. I think it was the notes are messed up there. No, okay. I'll pull it up right now. 8 over. So doc B, we have control divide 8 over 4 minus x squared.
Okay.
So this is what I was looking for. So on the right-hand side of 2, if you look, it is going also to 0. So the left side is going to 0, the right side is going to 0. But now in between, what is happening here? So from the left,
Wait, where's
left hand, from the left, as it's coming towards this way to positive 2, what's happening there? It's going up to
infinity?
positive infinity. It's going up to positive infinity. So if this was a left hand, it would be going up to positive infinity. Now, same thing from this side, from the right side at negative 2. It's also going up to positive infinity. Now, let's look at it. So from the left of negative 2, it's going to what?
Negative infinity?
Negative infinity, very good. And from the right of positive 2, it's going to?
Negative infinity.
Very good. So they're going to different things for each one of these. And that's what we identified, because when we found the asymptotes, that's where everything changes. That's where we're going to get where it's going to infinity and beyond. Does that make sense? Hopefully. Kind of.
It's for now.
Okay, yeah, it's a graph. So how about this? Let's pause it up here, and then we'll pick up again tomorrow. So make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Yeah.